Distinguished guests, ladies and gentlemen, and friends, on behalf of GEIDCO, let me release the interconnection technology and equipment innovation. And the agenda is like this: an overview, UHV and new types of power transmission, smart grid, clean energy, operation control of interconnected power grid, etc. First, that comes to the interview, and our research guideline or this rationale is to focus on key issues faced by the development of GEI. Propose UHV AC power transmission, electricity dispatch and trace simulation, and clean energy and power generation as the 4 major directions with 13 technical fields and 54 types of key technology and equipment. We'll study the status quo of development, future demands and research directions, and chart a roadmap for innovation, respectively. The report will lead technology innovation to assist in the GEI backbone grid build-out, facilitate large-scale development of clean energy, accelerate comprehensive integration of electricity-centered energy systems, and ensure a safe, reliable, and economic operation of GEI. This report can provide insight and guidance and reference for all parties in the energy sector, including research institutions, manufacturers, and utilities. The highlights are as follows. First, they capture leading-edge technologies. It comprehensively reviews the development status of a key technology and equipment for GEI and clearly points out the research directions. Second, this is goal-oriented. It's focused on the goal of GEI development while proposing 54 key types of technology and equipment and their future requirements for innovation. Third, it features scientific appraisals and analysis. It conducts systematic analysis on each key technology and equipment to propose a major R&D direction and roadmap for innovation. Second, UHV and new types of power transmission. It includes UHV AC technology and equipment, UHV DC technology and equipment, and new types of power transmission, as well as 12 types of technology equipment. So far, for UHV AC application, it is mainly in China. By the end of 2017, we have 8 lines in operation with a total length of 9,970 kilometers. There are 17 ongoing 800 kV UHV DC projects in construction in China, Brazil, and India. By the end of 2017, the total length of a UHV DC line is 24,022 kilometers. Now we need to focus on 1100 kV plus UHV DC transmission technology. We need to make breakthroughs in submarine UHV DC cable transmission. And we also need to address the extremely cold and hot ambient conditions. We also need to make a breakthrough in the 800 kV VSC UHV DC high voltage DC circuit breaker and other DC transmission technology. Now let's take a look at the future of UHV AC technology research. First, UHV GIS. It can withstand extremely cold and hot and other extreme conditions. And second, UHV series capacitor and the UHV controllable shunt reactor. UHV power flow controller, and UHV control and protection equipment used for transnational and intercontinental power grid interconnection. Talking about UHV-DC technology directions, it includes a prototype of 1500 kV converter valve, converter transformer, and instrument transformer, and 1500 kV gas-insulated DC circuit breakers and DC bushing. And also we need to have a DC circuit breaker. And UHV flexible DC, UHV DC cable, 100 kV and control and protection equipment for high DC power transmission. For the new type of power transmission, we need to look at high capacity, highly available superconducting power transmission technologies. And 800 kV UHV DC GIL line segment and engineering applications. From now to 2025, for UHV technology R&D, we have this roadmap. We'll have theories, equipment, demonstration and application and rollout in 5 stages. Thirdly, let me talk about smart grid. It covers AC power transmission and transformation, DC grid, power distribution utilization, and information communication. It encompasses 23 types of equipment. Now, SVC and STATCOM, as well as other VSC equipment, is widely in use, and it's developing towards high voltage, large capacity, and multi-objective coordinated control. And in countries like the United States, European countries, Japan, and China have carried out active distribution networks research. And electric vehicles, distributed cloud data centers, and artificial intelligence are also rapidly growing in this area. In the future, we are going to focus on power generation, transmission, transformation, distribution, utilization, and dispatch, secure, reliable, economical, and efficient operation of the power grids, and facilitate the integration of various clean energy sources. Also, there will be R&D on new integrated technology and equipment of power grids with cloud computing, big data, Internet of Things, mobile Internet, and provide a basic platform and services for building GEI. Let's take a look at the AC power transmission. We're going to focus on the power transmission equipment and the HV equipment, substation, and other power electronics. And the 500 kV smart transformers, and we're also making sure that the operation and maintenance is automated. Let's take a look at the DC research. First, the high voltage DC and DC converters, and the DC grid control equipment, DC grid power flow controller, DC grid fault current limiter, and the application in 500 kV, 800 kV grids. For the controllers, we're going to look at the topological structures and test methods. Now, of distribution utilization, we're looking at active distribution network, ADN, power utilization, charging and discharging of EVs, and the onshore power supply at ports such as integrated, modularized, and compact, complete equipment of onshore frequency variable power supply systems. Now, for information communication, the future research will encompass communication infrastructure, the early warning and predictive system, distributed cloud data center, intelligent big data analysis platform with quantum encryption, AI recognition, information security, and credibility. This is the action plan from now to 2025 in terms of the equipment for the GEI. Number 4, let's take a look at the clean energy and related equipment. first of all, clean energy power generation, large-scale energy storage, clean energy DC power collection, and operation and control of clean energy involving 15 types of equipment. Now the solar PV is becoming more and more mature along with wind. They are becoming more of an alternative energy, and the storage technology is making a lot of progress. Lithium-ion battery is dominant in incremental capacity. Countries like Germany, Netherlands, and Denmark have carried out clean energy generation characteristics and control research so as the adoption of clean energy. And China has gained a lot of experience in large-scale development of clean energy, high-voltage grid connection, long-distance transmission, and wide-area consumption. In the future, we'll focus on large-capacity and high-parameter wind turbines, high-efficiency and low-cost photovoltaic power generation, large-scale ocean energy, geothermal energy, while studying clean energy power collection technologies such as offshore substation of wind farm. We're aiming at breakthroughs in operational control technologies for virtual self-synchronization of wind power, photovoltaic, etc., to improve the economicalness, stability, and security of clean energy generation. Talking about clean energy power generation equipment, we're going to focus on the integrated onshore wind turbines and the offshore wind turbines for low temperatures, holistic solutions for offshore wind farm, solar power generation technologies, hydropower generation technologies, and thermal power generation technologies. For thermal technology, there will be cycle generation technology with high efficiency, and for the energy storage technologies, we're going to focus on pumped storage and the wide area coordinated control technologies, and electrochemical energy storage, large capacity and high temperature thermal storage, and large capacity and high efficiency hydrogen storage, large scale hydrogen production technologies, and hydrogen power generation technologies such as fuel cells, and hydrogen storage and transportation technologies. For clean energy DC power collection, we're going to focus on the collection system, reconfigurable DC power collection system control and protection devices of clean energy DC power collection system, DC-DC converter for large-scale HVDC power collection system, and for the operation control of clean energy, we're going to focus on coordinated grid generation control of clean energy, operation control of distributed clean energy, and microgrids, which can achieve plug-and-use possibility, and the use of virtual synchronous machines, the VSMs. This is the clean energy generation equipment R&D outlined toward 2025. Number 5, operation and control of interconnected power grid, including electricity dispatch and trade simulation, real-time dispatch, and security and stability control. For intercontinental electricity trade, we need technical support, and as well as the other 3 projects. In Europe, several regional power markets and around 20 power exchanges have been formed, and the transnational operation has been realized. In China, we have put in place the State Grid Simulation Center, which is used for the analysis and real-time simulation of the grid. And in Europe, they have talked about real-time sensing and warning system. Canada, US, Japan, and many other countries have put in place various levels of defense and security system. In the future, we're going to focus on security and stability analysis of ultra-large hybrid AC/DC power grids and build a new generation of a simulation platform to improve the efficiency and accuracy of calculation. We need to make breakthrough fault diagnosis, recovery, and auto reconstruction technologies to improve defense capabilities of large power grids under conditions of extreme weather, failure, and external damages. Let's take a look at electricity dispatch and trade technical supporting system for intercontinental electricity trade and simulation platform for global interconnected grids. And in terms of real-time dispatch and security and stability control, the key research projects include a technical support system for global interconnected grids dispatch, intelligent collection of a multi-source data of power grid operation, AI-based creation of ideal plan for power grid operation, and the security control of a global interconnected grids, such as protection for wide area self-adaptive system. Well, that concludes the global energy interglobal connection technology and equipment innovation outline. With the ongoing progress made by GEI, the related equipment will be confronted with a new round of innovations. The GEIDCO is inviting equipment manufacturers, researchers to join hands with us so as to putting partnerships for science and technology research in order to the R&D and application of relevant technologies of GEI, so as to make contribution to clean, low carbon and sustainable development of mankind. In the drafting of this report, we have enjoyed a lot of support from members and partners. On behalf of GEIDCO, I'd like to say a heartfelt thank you.